All right, so in this one, we're going to look at some non-polynomial functions, but we're doing the same thing as what we were doing in the last. We're going to find where it's increasing, decreasing, max and min, concavity, inflection points. So, and it's going to be the same process, but these are non-linear, so we can see how that works. But still, first we're going to take the first derivative. So f prime of x, and these, of course, will be uh, I mean, not super tedious, but a little bit more tedious. We have to use the product rule on this one. So we'll have 5x for the first part, e to the negative 0.2x for the second part. So the derivative of 5x is 5. We're going to have e to the negative 0.2x. And then we're going to hold the 5x the same, e to the negative 0.2x, and then the derivative of the negative 0.2x, which is negative 0.2. And then we can simplify this a little bit. 5 times negative 0.2 is just negative 1. So this will be minus x e to the negative 0.2x. And we're setting this equal to 0. And so what we can do is we can factor out the e to the negative 0.2x, which I forgot the x right there. So factor that out. And we're left with 5 minus x, and that is equal to 0. And so now what we're gonna be using this a couple of times. This fact is this is never 0, and we're also going to use this later. That is also never negative, so it's actually always positive. So we can divide both sides by that. We're just left with 5 minus x equals 0. So the only solution is x equals 5. And now we can do a similar thing. Of course, you can pick points and plug them in and do a test point, but you can also use a little shortcut. This is always positive because we're only concerned with, are we negative or positive? This is always positive. So the sign of the whole expression there, or the whole first derivative, depends on 5 minus x. So 5 minus x is positive, the whole thing is positive. 5 minus x is negative, the whole thing is negative. So when we plug in 0, say, it's going to be positive. So it's positive over here, it's negative over here. All right, so that means we are increasing from negative infinity to 5. Also, always, I mentioned this on the polynomials, but polynomials, the domain is always negative infinity to infinity. So it doesn't matter too much, but you should always be aware of the domain. This one, exponential functions, the domain's all real numbers, as long as there's nothing fancy going on in the exponent. But always pay attention to that because we're going to do a logarithm in a minute where domain is not all real numbers. Then we're decreasing from 5 to infinity. All right, so increasing and decreasing. So that means we have a max, but we do not have a minimum. So the maximum, we're going to plug in 5. So f of 5. And you don't need to put this in the calculator because you have to keep the e. You can't type an irrational number like as a decimal. So 5 times 5, well, we'll write this out. 5 times 5, e to the negative 0.2 times 5. And so we have 25, and that's going to be e to the negative 1. So we'll just put 25 over e. And then, of course, no minimum. So no minimum because we increase, and then once we start decreasing, we never stop. So it's going to go down to probably what the horizontal asymptote is, but we're not worried about that. All right, so actually, I guess I'll go to negative infinity. F double prime. So now we're going to take the derivative of that one. or you can do that one, either way. So we have 5e to the negative 0.2x. And let's see, maybe we should move down. I don't know if we have enough room here. So let's see, we'll write our first derivative here again. So f prime of x is 5e to the negative 0.2x minus xe to the negative 0.2x. And we're going to get the second derivative. So 5e to the negative 0.2x times negative 0.2. Now we're going to use the product rule on the next part. So we'll take the derivative of x, hold the e part constant, and then switch it around. So minus x, take the derivative of e to the negative 0.2x, and times the derivative of the exponent. And now let's simplify this. So 5 times negative 0.2 is negative 1. And plus 0.2x e to the negative 0.2x. And then we can combine our like terms. We'll set this equal to 0 at this point. And this is what we have. And so now we need to solve this for the x. Same thing we're going to do. Factor out the exponential part. And we have negative 2 plus 0.2x. And again, this part never equals 0, so we really just need to get this equal to 0. So 0 equals negative 2 plus 0.2x, and I'll solve that, I'm sure, on your own, and you get x equals 10. All right, so now let's put that on the number line. And we're really looking at the same thing as far as how to do this quickly. This is always positive, so the sign of the second derivative depends on this part. So when is this part negative? When is it positive? Again, like we talked about in the last one, in the last video, this is a positive slope linear function, just the part in the parentheses. And so we're going up like that. So it's going to be negative until we get to the 10. It's going to be positive after the 10. So concave down, concave up. So concave up from 10 to infinity, concave down from negative infinity to 10. And then inflection point, since it does change signs, the second derivative changes signs, then we'll have an inflection point at 10. So we just need to plug in 10 into the original. So the original f of x equals 5x e to the negative 0.2x. So plug in 10, we get 50 e to the negative 2. And so that would be 50 over e squared. And there's your inflection point. Again, I think I mentioned this in the last video. I kind of, when we're doing these, I'm skipping through the algebra part as far as plugging things in. I'm going to assume that you can plug in 10 and simplify this without having to write it all out. So just to save time for me and you possibly. But anyway, so that's what we have there. All right, so number 7. So now we're going to have a rational function. We're going to do the same thing. When we take the derivative, we need to use the quotient rule. So we have the bottom times the derivative of the top minus the top times the derivative of the bottom. And then that's all over the bottom squared. And so now we can simplify. So we have 2x cubed plus 6x minus 2x cubed all over x squared plus 3 squared. and then the 2x cubed cancel out. So we have 6x over that denominator. And now we're going to set this equal to 0. And of course, don't have to worry about, normally you always want to check and make sure the bottom, where is the bottom going to be 0? Let's see, I'm going to fix that. That's not a B, that's a 3. Look like a B. All right, squared, 0. All right, so this can never be 0, so you don't really have to worry about that. 6x equals 0 is all we got to worry about. So x equals 0. That's the only solution to that equation. And, oops. So let's see, we'll do this over here. So 0, where is this positive? Where is it negative? Something to notice, the denominator is always positive. So we're squaring it, so it has to be positive. So the sign of this is completely determined by the numerator. So when the numerator is negative, this is negative, numerator is positive. Sorry, this is positive or negative. So when x is negative, the first derivative is negative. When x is positive, the first derivative is positive. So we're increasing from 0 to infinity. We are decreasing from negative infinity to 0. And then, so we're decreasing, increasing. And again, I mentioned on the last problem, pay attention to the domain. X squared on top, of course, all real numbers. X squared plus 3, all real numbers, and is never 0. So this domain is all real numbers because there are no asymptotes that we have to worry about. All right, and then, or at least vertical asymptotes, I guess. We want to be very specific. All right, so we have decreasing, increasing, so that means we have a minimum but no maximum. So maximum does not exist, and then the minimum, plug in 0, so f 0, which is 0. So 0 squared over 0 squared plus 3. All right, so that takes us to the second derivative. And so our first derivative is 6x over x squared plus 3 squared. So we got to use the quotient rule again. So the bottom times the derivative of the top minus the top times the derivative of the bottom. So we're going to bring 2 down. So 2 times x squared plus 3, subtract 1 from the exponent, so that's a 1 now, and then times the derivative of x squared plus 3. And then all over x squared plus 3 to the 4th. Square that bottom part. All right, so now let's simplify all our like terms. Oops, multiply everything out. And we're setting this equal to 0. So don't FOIL out x squared plus 3. That is not necessary. So we have 6x times 2 times 2x. That'd be 24x squared. And then 2x squared plus 3. And then all over x squared plus 3 to the 4th. All right, so now we have x squared plus 3 squared. We have x squared plus 3. So let's pull that out. And we are left with 6 times x squared plus 3 minus 24x squared all over x squared plus 3 to the 4th. All right, so now that will cancel. Now it'll become a 3. We can, let's just move this up here. And so we have 6x squared plus 3 minus 24x squared over x squared plus 3 to the 3rd. And distribute 6. whoops, 6 times 3, 18. Minor like terms. So we have negative 18x squared minus plus 18. And that is equal to 0. And again, the denominator can never be, oops, did it again. The denominator can never be 0 here. So x squared plus 3 is always positive, cube is always positive. So it can never be 0, never negative. So the sign of this, or the sign of the whole thing, is determined by the sign of the numerator. And you set that equal to 0, negative 18x squared plus 18, x is plus or minus 1. And sorry, we're running out of room. Negative 1 and 1. Again, we only really have to worry, as far as what we're plugging in, we only really have to worry about this numerator. So you can test points. You can plug in -2, plug in 0, you can plug in 2, whatever it is, anything in these intervals to see what the sign would be. But we can also see this is a quadratic, and it has a negative leading coefficient. So the quadratic is going to look like that, where there's your -1, there's your 1. So it's negative up to there, and then it's positive in the middle, and then negative. So concave down, concave up, concave down. And I'm not going to write the intervals just because we're running out of room. But negative infinity to -1, 1 to infinity, where it's concave down, and then -1 to 1 is where it's concave up. And then the inflection point, so these are both inflection points because it changes signs on both of them. So -1, we're going to plug in, I'm not going to scroll up, but we're going to plug in -1 in for f into the original. So we have -1 squared over -1 squared plus 3, which comes to 1/4. And then we're going to do the same thing with 1. And we get the same thing since we're squaring 1 anyway. So it's not changing anything. All right. So not too hard, but you got to know your product. You got to know your quotient rule for this one. And then make sure to look out for it. So normally you probably don't ever need to FOIL out something like this when you have a long expression like this. Don't worry about foiling it out. See if you can factor something out first. It'll save you some time. I guess if you multiplied all it, if you did, well, obviously, if you did multiply all this out, you'd eventually end up with -18x squared plus 18, but might take you a little while. All right, and then so the last one is a logarithm. And so the thing to make sure you remember about this, and obviously you check it on all of them, but normally the domain is all real numbers a lot of times. But when it's not, you got to make sure, because otherwise you're going to get a wrong answer. So we're going to do the same thing. Keep in mind the domain. So use the product rule. So we're taking the derivative of x, holding ln of x, and then holding the x, taking the derivative of ln of x. And then this is, oops, this is ln of x plus 1. And so we're going to set that equal to 0. And x is e to the -1, or whatever e. And so let's put this on a number line. Now these you're going to have to actually plug in numbers. So we can plug in 0, and 1 over e is some decimal less than 1. So pick a number like 0.1 or something like that and plug it in. We get a negative. Pick a number up here bigger than 1 over e. So you plug in e if you want. Plug in e, and you get ln of e is 1. 1 plus 1 is 2. So this one is positive over here. So we are increasing from 1 over e to infinity. We are decreasing from not negative infinity, but 0 to 1 over e. You want to make sure it's a parentheses, not a bracket. And then if you like, decreasing, increasing, so we have a minimum, not a maximum. So the minimum, we're going to plug in 1 over e. So f of 1 over e is negative 1 over e. And then maximum is none, does not exist. All right, and then we'll look at the concavity. Let's get all right, so the f double prime. So we're just going to take the derivative of ln of x plus 1, which of course is just 1 over x. All right, now, obviously we cannot solve 0 equals 1 over x. That has no solution. And since the domain is all positive numbers, this is always positive. So f double prime is positive for all positive x. Negative x is not in the domain, so don't need to worry about it. So since it's always positive, that means we are concave up on the entire domain. And that means that we're never concave down and no inflection points. All right, so hopefully, I think that's every type of problem that you will see. Again, the more you practice this, the easier it will get. You can see through these last two videos that they are very repetitious as far as what we're doing. First derivative, increasing, decreasing, max and min. Second derivative, concave up, down, and inflection points. All right, so if you have any questions, feel free to email.